Hello, Owls. This is another week of ACT Prep. Today, we will be covering properties of geometric figures. A couple things to note. You'll need some materials, right? Pen, pencil, something to write on, maybe dry erase boards, maybe dry erase markers, whatever you want to do as a group. You'll probably need a graphing calculator to do some of the mathematics. And then the two biggest things, I really like the willingness to learn and having a positive attitude. Well, you sure didn't see that bigger, more expressed than this past Saturday with the soccer team. Definitely had some adversity this year, but they expressed a positive attitude and a willingness to learn, and look what they were able to accomplish. Imagine what you can do if you did exactly the same thing. Well, let's go ahead and get started with this. Couple things to note when we talk about properties of geometric figures. Things are drawn to scale unless you are told otherwise. Also, you should note that a triangle, if we add up all the angles, it should always add up to be 180 degrees, which then asks the question, what would a rectangle have? Well, you could divide it into two triangles. So that would make 360 degrees, right? Because each triangle would have 180. We could go further. We could make a five-sided shape. 1, 2, 3, 4, 5. Break that up into triangles and see that there are 3 triangles. So we would have 540 degrees. It's kind of a nice idea. And the other one is this, that if we have 2 lines that are parallel cut by a transversal, then there's lots of angles, like these green angles are equal to each other. In fact, all the green angles are equal to each other. And all the red angles are equal to each other. These are really the basic ideas of things that we will need to do these problems. So let's look at this first one, a parallelogram. What is the value of x? Well, it's a parallelogram, so when opposite sides are parallel, and I may not remember some of the properties of a parallelogram, but if I were to extend out these sides, this angle is 25. Well, so is this one over here, right? Because of what we were talking about. And then these two angles together form a straight line. So I could think about 180 minus 25, which would give us our answer of 155. Okay. All right. I want you all to try question number 5. I'm going to give you 40 seconds. Okay, 20 seconds left. All right. Looking at this, we are told to find the measure of angle C, and we're told that AB is parallel to DC. So I know that these two sides are parallel. In fact, they look like they're parallel. Well, remember, things are drawn to scale, and we are trying to find angle C. So, you can always use the corner of your paper to estimate for a 90-degree angle. And if I were to take this rectangle with a 90-degree angle, I could tell that, that angle C is just a bit bigger than 95 degrees. So based purely on drawn to scale, I would say the answer is B, because everything else is way off. For sure, this one and this one, right? And since it's so close to 90, I would go with 95. But we would like to do the math on this as well. So if I were to extend this side like we did before, and here's the two sides that were parallel, this angle is 85, so is this one. And we're trying to figure out what this angle is here. So if I just did 180 minus the 85, I would get 95. But I do think the drawn to scale is really a lot faster in this one. Okay, let's look at number 22. They tell us, and they want us a bunch of information, and they say, what is the value of angle Y? Well, again, this is drawn to scale. So if I were to think about, piece of paper, corner of the paper makes 90 degrees, right? Hold that up. I could tell that angle Y is going to be bigger than 90. So I should be able to eliminate those. And it looks like it's just bigger than 90. So based purely on drawn to scale, I'm going to choose letter J. Now let's do the mathematics and see if this is in fact correct. Well, this is a four-sided object, and we just saw earlier that if we have four sides, the sum should be 360, all the angles. So if I add all these up, 2x and 2x and 3x and an x, that adds up to 8x. And then the numbers here are really nice. Positive 25 and a negative 25, that adds up to 0. Positive 10 and a negative 10, that also adds up to 0. So all four of those angles should add up to be 360 degrees. So we divide both sides by 8, use our calculator, and we wind up with x equals 45. Notice the halfway answer here. Some people may select 45. Since it's drawn to scale, you should have eliminated 45 as a choice. You would not fall for that mistake. They want to know what angle Y is. Well, here's the angle that's right next to it. So 2 times 45, subtract 10, would wind up with 80. And if that angle is 80, then the outside angle must be 100. Again, I think the drawn to scale is a pretty cool way to get that, much quicker. All right. Let me give you all 30 seconds and have you try this number 7. Okay, 10 more seconds here. Okay. It's a parallelogram. And one of the properties of a parallelogram is opposite angles are equal. But even if we didn't remember it, it sure looks like those two angles are equal. They are. And then I can just look at a triangle here. We know all the angles in a triangle add up to be 180. So if I were to subtract the 57 and subtract the 40, we would wind up with the answer of 83. Now again, what we should have done was at the start, that this is drawn to scale, right? I should compare this angle to 90 degrees. And I should tell that, boy, that angle is just a bit less than 90 degrees. So we would definitely get rid of everything else and keep the letter D just by being drawn to scale. Okay, drawn to scale is a really great way to get this stuff. Okay, now one thing you'll notice on ACT prep is that as you do more and more math questions, you start seeing things repeated. These 3 questions appeared on 3 different ACT exams, but you'll notice they all look very, very similar. We're going to do the first one together, and then I'm going to have you do the other 2 problems, all right? They tell us that the perimeter of a parallelogram is 80 inches. So what we should do is we should draw a parallelogram. Now, earlier, we just saw what a parallelogram looks like, right? This is a parallelogram. So I'm going to draw that as best I can. Now, we're told that one side is 16. Well, if one side is 16, the opposite side also has to be 16, right? Because it's a parallelogram, opposite sides parallel. And wants to figure out the other 2 sides. Well, we've got a total of 80 inches here. So if I subtract both 16s from there, I will wind up with 48, right? 48. Now that 48 is what this side plus this side will equal, 48. So I think the remaining two sides must be 24, right? So which one matches up with that? It's letter H, right? Okay, I want you all to do number 20, the next two problems here, okay? They're done just like this one. I'll give you a minute to do both. Okay, about 20 seconds left here on both of these. Okay. Well, we're told that the parallelogram had a perimeter of 96. So I'm going to subtract both 16s from that 96, and I will wind up with 64. So that means the other two sides must be 32, right? Because they are both equal to it. So there's our answer. On the other one, we're told that we have a perimeter of 84. If I subtract both 16s from that, that would be 52, which would give us 26 for the other two sides. And there's our answer, letter H. All right. Hey, everyone's doing pretty well. We've been at this for about 9.5 minutes here so far. Good work, everyone. Okay. On the left-hand side, here's another problem. And this is part of like a multi-step, like there's about 5 other questions to go with this. That's why there's a lot more information that we're not going to use here. What they ask is, what's the measure of PQR, right? I'm sorry, blah, blah, not that, sorry. What's the measure of BAD? So they want to know, what's this angle up here? Well, again, it is drawn to scale. So if I were to take a piece of paper and hold it up to that to see, I can tell that that angle is bigger than 45 degrees. So I would definitely get rid of those two. And I think it's a lot bigger than 45 degrees. So I'm thinking, like, if I had to take a guess, I think I would guess letter D. If I wasn't going to do any of the geometry work, I would just guess letter D. But this is a parallelogram, right? Because we are told parallelogram. So if I were to extend out these sides, add up these two angles here, 71 and 42, which is 113. And that means that angle up here is also 113, right? Because these are both green angles. So 180, take away the 113, will give us an answer of 67, which is what we got by just doing the drawn to scale. Drawn to scale is pretty big in the geometry part. It definitely helps you out sometimes. Okay. Here's another one. They go ahead and they give us some vertices. And they say, once you plot those, what shape would you have, right? So let's go ahead and plot these up and just see what we have here. So -2, 0 is right there. 0, 4, 5, 5, and 8, 2. Okay. And I'm going to connect these. Well, let's see the choices that we have here. I don't think it's a kite, right? Because kites look like that, or they look like that. And it definitely is not that one. It's not a parallelogram because, you know, parallelograms we know look like this. Trapezoid, probably, but let's see, rectangle, no, square, no, yeah, it's got to be a trapezoid. Again, definition of a trapezoid is that there's one set of parallel sides. That's it. Okay, good. All right, let's continue on here. Now, I went ahead and put a grid in for this one because they kind of ask you about drawing on this. This number 25. They tell us each side of the square is 4 centimeters long. And one vertex is at 6,2 on a grid marked in centimeters. So this whole grid is marked in centimeters. I'm going to mark off 6,2. Here's 6,2. So the deal is we need to figure out what could be another vertex of a square. Well, if that's the corner of a square and each square has got a length of 4, we could have a square up here, right? Or we could have a square here using that, or a square down here, or a square down, and I mean, like, you know, we could have like that square or this one. These are simple ones, right? But there could be more bizarre ones. Let's just go through the choices here. 10,2. Oh, wow. There it is, 10,2. That's the answer, letter A. I'm not going to bother checking the rest because it's an ACT, right? I got the answer. If I had time left over, I'd go back and take a look. But, you know, if we do, let's see here, 7,3. There's 7,3. That's definitely not on the vertex. 2, 5. There's 2, 5. That's not on a vertex. 1, -5. -4, 2. Yeah, none of those work. This is the one. Cool. All right. Let's keep it going here. Okay. Question number 57. It tells us an angle in a pentagon. The angles are in this ratio. So the angles could be like 20, 30, 40, 40, 50. Or they could be, if you multiply those by 2s, it could be, you know, 8, 6. I'm sorry, 4, 6, 8, 8, 10, whatever. We're not sure what it is, but that's the ratio. Now, we're dealing with a pentagon. If we have forgotten, if I were to draw a pentagon out, 1, 2, 3, 4, there's 5 sides. And I kind of break it up into triangles, I could see that there are 3 triangles, and each triangle has 180 degrees in it. So if I did 3 times 180, I would wind up with 540 degrees. All the angles must up to 540. Well, here they are, right? So we've got, if I add up all those pieces, these all add up to 18, but they're all multiplied by something. So I'm going to say 18 times x. Not sure what x is, but it's got to give us a total of 540. Divide by 18, we wind up with 30. Okay, now be careful, right? They want to know the largest interior angle. Well, the largest must come from this one. It's got the 5, right? So let's go 5 times 30 to get the biggest angle, which is 150. Choice C. Now notice, you know, that's number 57. That's pretty late in the test. Supposed to be one of those really, really tough ones. Here's one that's earlier in the test. Same thing though. But they're going to give us 4 angles and you have to find the 5th one. I'm going to give you 30 seconds to use your calculators and come up with what that 5th angle is. Remember, We already found out the sum is 540. Okay, so hopefully everyone took your calculator and just subtracted 70 and the 100 and the 110 and the 135 from that and got an answer of 125 degrees. Okay, so this was hinged upon knowing that the sum of the angles in a pentagon is 540. But, just draw yourself a pentagon. Penta means 5. Break it up into triangles. There's a formula too. It's n minus 2 times 180, but a lot of times you can't remember that formula. So don't try. Just draw yourself a picture and figure it out. Okay, here's number 23, and this is a very rare problem. It's not drawn to scale. Yeah, it's not drawn to scale. How do we know that? Because they tell us. This is let's see, the most recent example. So it's from 2016. And everything's been drawn to scale. Like I think only like 3, this is like the 3rd time something has not been drawn to scale. Man, crazy. Well, we're supposed to relate these, and these are side lengths, right? So we have here, which side's the biggest? Now, if it was drawn to scale, I think we'd all say letter B, side B is the biggest. But you should remember in geometry, and this is a pure geometry knowledge question, it's 23, so it's kind of rough. The biggest side is always opposite the biggest angle. So C has got to be the biggest side. So I can get rid of 3 choices just based on that. Similarly, the smallest side is opposite the smallest angle. I think we would agree that x is smaller than 3x, okay? Well, if A is the smallest, I think it's got to be choice A, right? Because A is the smallest, whereas in C, they're saying letter B is. Yeah, not drawn to scale, kind of neat. But again, they tell you this, right? All right. This is number 51, but really, I think it could be like number 21. It's a pretty easy one. So I'd like for you all to draw this. Now I put the grid in for us. AZT did not provide the graph paper, but I'd like you to draw this for me, okay? Everyone take 30 seconds, figure out what the answer would be. Okay, well, first they tell us y is equal to 4. So that's a horizontal line going through 4. And we can think about it because all the y values here, they all have a value of 4, right? All the y values have 4. That's why we're that way. And then x equals -3. Well, that's this line. That's bad. Every single point on here, the x value is always -3. And then y equals x, right? And they want to know it. They found a triangular region. I think we can see that triangular region. And the question is, what's the name of it? Well, let's count some sides off, right? If we count up the number of squares horizontally, there's 7 squares there and there's 7 squares here. So I could think right away, it's got to be isosceles. Isosceles means that the 2 sides are equal. And then this is a right angle, right? So it must be a right isosceles. Not too bad. Okay. Okay, we're getting short on time. We're only gonna do one more. We're not gonna do this question number 35 on the right. We're gonna do this number 48. I really like this one because it's probably the most difficult one, and it's really, really interesting. They're gonna give us the side lengths of a triangle, 4, 5, and 7. And they say, which one best describes this triangle? Well, we should draw a sketch, right? I'm gonna kind of pretend it's a right triangle. It's not, okay? And this side would be 4 and this side would be 5. I'm not sure if the hypotenuse is 7 or not, but it's got to be the biggest side, right? So I'm going to call that side C. I'm going to do my Pythagorean theorem here. Now I wind up with 41 equaling C squared, or C is equal to the square root of that, which is about 6.4. So this side here has got to be 6.4. If this is going to be a right triangle, that must be 6.4. Now, first off, I think we can get rid of J and K because of the word isosceles, right? These sides, 4, 5, and 7 are not the same. So we know it's some form of scaling. Question is this a right angle or not? Well, they want the hypotenuse, right? They want that hypotenuse to be a length of 7. But we know if it's a right angle, it's gonna be 6.4. So if I'm gonna try to cram 7 in there, which is bigger than 6.4, I think this right angle is gonna have to, it's gonna have to get bigger. So that would make the angle obtuse, right? Remember, smaller than 90 is acute, bigger than 90 is obtuse. So it's got to be obtuse. All right, well, hey, thanks for the math work today. It was a good 24 minutes of good mathematical work. Again, if you keep practicing, you're going to get better and better and better. Handle that adversary just like that soccer team did, and they pulled off the win. So good luck to you all, and we will see you in a couple weeks.